Assalamu alaikum everyone. My name is Ghassan Halim Mohsen. We are Group 3. We are going to present our section Semiconductor Dosimeters. What is the radiation? Radiation is energy that moves through space or matter at a very high speed. This energy can be in the form of particles, such as alpha or beta particles, which are emitted from radioactive materials, or wave, such as light or heat. Why to detect radiation? For environmental safety, personal protection, calibration of radioactive isotopes, power regulation in nuclear reactors, research applications, and estimation of radiation. Some characteristics of radiation detectors: sensitivity, lifetime, resolution, less dead time, operating voltage regarding radiation detection range. How to detect radiation? We choose a radiation detector working on particular principle of interaction, ionization. What is the dosimeter? The ionizing radiation, which is, for example, emitted from radiative substance or generated by X-ray equipment. The effective dose can be determined with a special measuring, namely dosimeter. This dosimeter wound by the pupil who are exposed to ionizing radiation, in a particular depending on the job of the pupil are doing. The central task of dosimeter is to measure the energy of the radiation that the human body has received over the certain period. Dosimeter should not be confused with Geiger counter. The Geiger counter indicated known radiation intensity, but not the sum all of previously received the radiation dose. Some dosimeters have an additional function of being able to warn in advance, indicating the area where the ionizing radiation is intense. Those dosimeters help the person keep the dose at minimum. There are active dosimeters, which indicate to the user the actual dose value straight away and can, if necessary, warn if the predetermined value is attained. Dosimeters are mandatory in a nuclear power plant. The passive dosimeters, however, usually measure all doses taken in a month and add them together. Some groups working with radionuclide that emit only a smaller radius. In this case, for example, there are ring dosimeters which can only measure the dose in the finger skin.
So there is multiple types of dosimeters available in the market, but now we want to focus about semiconductor dosimeters. Okay, next is the types of semiconductor dosimeters. First one is silicon diode dosimeter. So what is silicon diode dosimeter? Silicon diode dosimeter is a p-n junction diode. P-type diodes are used for diagnostic radiology dosimeters since they are less affected by radiation damage and have a much smaller dark current, or we call it as a noise. So what is the principal operation of silicon diode dosimeter? When radiation falls on the diode, it produces electron-hole pairs in the body of the diode, and also current, which is generated in the reverse direction in the diode. Number of such pairs is proportional to the incident radiation dose. Due to the diode structure and the intrinsically formed potential difference, there is no need to apply a bias voltage across the P and N-type diode regions to collect the charge liberated by the radiation. The response of the diode in a current mode is complicated and can be affected by dose rate, temperature, radiation defects, and initial material. Okay, now we know about silicon diode dosimeters. Next one is MOSFET dosimeters. So what is MOSFET dosimeters? MOSFET actually stands for Metal Oxide Semiconductor Field Effect Transistor. It is actually a miniature of silicon transistor. So, how MOSFET dosimeters works? When MOSFET dosimeters are exposed to radiation, electron-hole pairs are produced in the silicon oxide. The positive charge carriers move in the direction of silicon to silicon oxide interface, where they are trapped, building up the positive charge, which causes change to the current and leads to a change of the gate bias voltage. The gate bias voltage change is a linear function of absolute dose. The integrated dose may be measured in real time or after irradiation. MOSFET detectors can be used in a passive mode and also active mode. Passive mode means zero bias on the gate during the irradiation, and active mode means that positive bias on the gate during the irradiation. Bias gate of the MOSFET detector increase the electrical field in the gate, leading to reducing of recombination electron-hole pairs created by ionizing radiation, and hence increasing sensitivity of the MOSFET and also linearity of the response.
The desirable properties of dosimeter are characterized by precision, linearity, dose rate dependence, energy response, and directional dependence. However, the response of dosimeter depends upon their construction, physical dimension, and angle of incidence of the radiation. It is imperative to quantify their desirable characteristics before the actual use and apply the necessary corrections.
The first dosimetric property is resistivity. Electrical properties of semiconductor can be indicated by resistivity. Conductors such as gold, silver, and copper have low resistivity and can conduct electricity easily, while the insulator such as rubber, glass, and ceramic have high resistivity and are difficult for electricity to pass through. Semiconductors comprising a single element are called elemental semiconductors, including the famous semiconductor, which is silicons. Semiconductors have properties somewhere between these two. Their resistivity might change according to the temperature. At low temperature, almost no electricity passes through them, but when the temperature rises, electricity passes through them so easily. The second property of semiconductor is energy dependence. Energy response is an important characteristic of a dosimetric system. Dosimeter may exhibit energy dependence, particularly for low energy beams, due to their high atomic number. It is difficult to find a dosimeter that is tissue equivalent and energy independence over the entire energy range used in radiotherapy. A study by Satish Kumar et al. They investigated the energy dependence of the MOSFET dosimeter for cobalt-60 gamma rays and 6 and 50 MV trays. In this research, the performance characteristic of mobile MOSFET dose verification system was analyzed for megavoltage photon beams. It was observed that the MOSFET response is energy and dose rate independent for measurements at depth beyond dm. Hence, this dosimeter can be used over a range of photon beam energy with no correction for energy and dose rate dependence. The third semiconductor properties is dose rate. In an integrated system, the dosimeter response should be independent of the dose rate, at which the radiation dose is delivered. The dose rate dependence of the dosimeter should be checked and appropriate correction should be applied in order to investigate the dose rate dependence and response. The reading for dose rate by using MOSFET dosimeter were obtained by irradiating them to 100 centigrade for dose rate by using 6 and 50 MV photon beams. It is observed that the MOSFET response is independent of dose rate variations and for variable field size. From previous study, there is a linear increase of semiconductor signal with temperature. The correlation found between the temperature and dose rate dependent points to a common basic physics phenomenon at their origin, probably related to the minor carriers in the crystal. While with the temperature, the higher the increase with dose per pulse, it is observed that there is a large dependence on dose per pulse for N-type and a negligible one for P-type diodes. The other dosimetric properties of semiconductor is reproducibility, at where the semiconductor detector have excellent reproducibility, good mechanical stability, absence of external bias, small in size, and the energy is independent of mass collision stopping power ratio.
Alright, moving on to advantages of silicon diode semiconductor dosimeter. It has high spatial resolution due to its small, well-defined high-density measuring volume, which satisfies the bright gray cavity theory. It also has higher sensitivity than IC of the same volume, which is very useful for kilovoltage dosimetry. There is no need to convert to high voltage supply, small in size, instant readout, and ruggedness. Alright, moving on to the disadvantages of silicon diode semiconductor dosimeter. Silicon diode dosimeter is not tissue equivalence and require calibration factor for temperature, dose rate, energy, and angle. It also needs connecting cables and produce radiation-induced damage after repetitive usage. Now, let's learn about the advantages of MOSFET semiconductor dosimeter. The small size of MOSFET produces little attenuation to the beam. It also has wide dose range, instant, non-destructive readout, compatibility with the microprocessor, high sensitivity to change in voltage bias during irradiation, independent of dose rate and temperature, and also no correction factor for megavoltage beams. The disadvantages of MOSFET are it has limited lifespan due to the accumulated radiation damage. The response of MOSFET also drifts slightly after irradiation, hence the reading needs to be taken in a specified time after exposure. It also requires individual calibration in different radiation fields. Okay, now we are going to look at the clinical application of semiconductor dosimeter in radiotherapy. Okay, the first one is the measurement in phantoms, in which silicon diode dosimeter is used for small field radiotherapy or SRT, which have high dose gradient area or so-called the penumbra region. In electron beam, we can also measure the depth dose using silicon diode dosimeter, which produces directly the dose distribution measurement. Silicon diode dosimeter is also used for in vivo dosimetry, which is used on patient or bladder or even rectal measurement provided with build-up encapsulation to protect from physical damage. Silicon diode dosimeter can also be used for measurement of relative absorbed dose distribution in high-energy electron beam radiotherapy. The MOSFET dosimeter is widely used in vivo dosimetry for various treatments such as IGRT, IMRT, and EBRT for measurement of entrance skin dose and exit dose. MOSFET dosimeter is also used for phantom dose measurement in high-dose rate brachytherapy due to its steep dose gradient. It also used for high-energy photon beam. This is an example of wireless MOSFET semiconductor dosimeter set up in treatment room. Not only that, MOSFET dosimeter can also be used for patient dose verification during quality assurance of patients, in which it was done before radiotherapy plan is executed to the patients. Next, MOSFET is also used during low-dose rate brachytherapy or LDR for prostate implant in order to assess the seeds implants in terms of dose and distance between the implants. Okay, since MOSFET produce direct dose measurement in HDR brachytherapy, it is used for quality assurance of the brachytherapy. After usual pre-treatment and checks completed, water phantom is assembled and plant QA is performed.
So that is the brief view about semiconductor dosimeters. That's all from us. Thank you for watching.